Hello, everyone. My name is Rashil Dalip, and we are presenting using image classification of Google Street View images of college campuses to predict college retention rates and discover environmental factors that affect these retention rates. Also presenting with me will be Mathil Patil, Tarun Mahesh, and Samuel Leo. So we will be going over 4 different sections today. The first being background information. The second will be our research, so what we currently are doing towards our project. The third will be our results, so what have we obtained with our current research. And fourth will be our future ideas and what we can improve on throughout our research. So first up is our background info. So we will have 2 different parts in this research. In the first part, where we'll take pictures from Google Street View and put them through different machine learning algorithms for different and accurate results. In our second part of our research, we'll collect characteristics of students such as their GPA, their SAT, their race, and their gender to find common factors between students that cause them to drop out. However, the second part of our research we will not be focusing on in this colloquia because we are still on our first part. So some background information about our research project. So there are many, what are retention rates? Retention rates are just the percentages of students that return to college after their first year. And we know that there are multiple different reasons as to why a student may return to a college or leave a college for that matter. So there have been many other studies that use Google Street View images, the first being predicting income level of neighborhoods. In this research paper, they use convolutional neural networks, which is also known as CNNs, to predict income brackets from Oakland, California. The second is predicting demographic makeup. So in this project, they used Google Street View images of cars across the world and a logistic regression model and tried to estimate the demographic of neighborhoods across the US. Third is predicting crime rates. Using CNNs and regression models, they tried to predict crime rates. And their results show that it is possible to predict crime rates based off physical characteristics of a community. And we chose this project because learning about the factors that cause a student to drop out are very important, and giving this information to colleges is also very important. So we have 3 main objectives in our research project. The first is the correlation between the physical campus of a college and their retention rates. This is the first part of our research and the main thing we are focusing on currently. The second part of our research is to find the correlation between the characteristics of students and retention rates. Characteristics of students include GPA, SAT, race, gender. And our main goal and overall goal of our research project is to use these results that we get and give them to colleges so that they may be able to better their environments to keep students in their college. So there have been 2 previous research papers on retention rates that we have found. The first is made by a person named Trivedi. So in this research paper, they collected information like gender, age, their ACT score, and their GPA, and put it through a support vector machine, which is SVM. They managed to get a 70% accuracy and usually managed to get above 70% when they predicted students who would come back to the college. The second research paper is Ruba A and Rosalind H. So their study was on underrepresented minorities in the STEM fields. They had a hybrid model which consisted of quantitative and qualitative data. Their quantitative data was gathered using a genetic algorithm that picked out factors that affected retention rates the most. Their qualitative data was gathered through an 8-question survey based on focus groups. Their model inevitably achieved a range of 74 to 79% accuracy.
Hi, my name is Tarun Mahesh, and I'll cover the first part of our research, which is the data collection. So our data collection consisted of 4 steps. The first step was creating a list of 35 colleges that we'd be collecting these Google Street View images from. We tried to get a diverse list of colleges because we felt our machine learning model would benefit from that. The second step was collecting the Google Street View images for each of the 35 colleges. We felt a good number of images that we should collect per college was between 80 and 100 images. We randomized where in the campus we were to try and get a diverse range of images per college. However, we decided to keep something standardized so that it wouldn't affect the performance of our model. This included the size of the image, the resolution of the image, and to make sure that no pop-ups came as the model would detect those. Step 3 is finding the college retention rates. We needed those because those would be the target variable in our model, where the images would be the feature variable. And the last step was to label the colleges. We would label the colleges based on retention rates, and we split them up into 3 labels. The 3 labels were a low label, a medium label, and a high label. We split these 35 colleges up so that we would have 12 colleges considered under the low label, 12 colleges under the medium label, and 11 colleges under the high label. And the retention rate percentages lined up so that there was 60 to 75% considered. Any colleges with 60 to 75% retention rates would be considered low retention rates. Any college with 75% to 90% retention rates would be considered a medium retention rate. And any college with 90% to 100% retention rates would have a high retention rate. This is a pictorial representation of how we collected our data. We started with a list of colleges, which was in the purple. And for each college, which is represented by the pink, we got 2 attributes. We have the images, which we collected through Google Street View, and we have the retention rate, which we collected per college. These are some example pictures from Google Street View that we took from Emory University and Cal State Dominguez Hills.
All right, my name is Mithil Patil, and I'll be talking about now once we had this data, what do we do with them? So our first attempt was to use color patterns. So our thought process behind this was basically when we look at an environment or when we look at an image, the first thing that comes out to us is color, right? That's the first thing we see. So if we can pull out the colors in an image, we should be able to train a model that can determine and find a connection, find if there is a connection between the colors and the ambience of a environment, and if that connects to the retention rate. So the way that we picked out colors was using k-means clustering, which is a machine learning process in which data points are plotted. On the right is a 2-dimensional example of this where they just plotted X and Y. So colors are represented using RGB, which is 3 values. So it would be sort of like the example on the right, but 3-dimensional. And then we split that, the formula basically calculates the distance between all the points, and it's able to find out, what is considered a cluster and what is not. And it's able to find out 4 generic common colors that are found throughout the image. And then the thought process was that over 1,000 of these images, right? We had 3,000 images in total. We could get a general sense of, okay, what colors are more prevalent in low retention rate colleges, what are more prevalent in medium retention rate colleges, and what are prevalent in high retention rate colleges. So eventually we had 4 colors for every single image that we had. So once we had all this data, we had to try to find this connection, and we used a decision tree classifier for that. So the way a decision tree classifier works, it's a machine learning model that is used to find what features, or like if you're looking at it in a table view, what columns matter the most. So in this case, it'd be what colors are going to have the most impact on retention rate. So what colors lead a computer to decide, okay, it's going to have high retention rate, or okay, it's going to have medium retention rate. So this is a very common example for understanding how decision trees work. And this is like, should I accept a new job offer? And there's 2 outcomes, right? There's either you accept the offer or you decline the offer. For us, we had 3 different outcomes, which was low, medium, or high. And the computer trains itself. That's what machine learning is. It trains itself to fill in these blue boxes, and it trains itself to find out, okay, if it's this color, then we go down one tree, or it's called a node, and if not, we go down the other one. So we tried this attempt, and we didn't get too great results. So we moved on to our another method, and that was, here's also an example image from our data set. This is a picture that we collected from Harvard, and these are the 4 colors that we were able to pull out from the image. So this model didn't work out too well. We didn't get the results we're looking for. So we moved on to another method. So we used image recognition. And what that basically is we're using support vector machines to in a way, teach a computer how to see. So a support vector machine is another machine learning tactic in which we plot every single point. Again, on the right, the X is a simple 2D representation where we just have X and Y values. The vectors we had were much larger, right? Because an image, each individual image has thousands of values, many data points, but the same idea applies. You plot all these points, and then eventually you sort of draw a line with a margin through the data to separate the data into groups. So here we have it separating into class A and class B. What we did was we sorted it into, we taught the computer to, it's sort of like a regression line that separates the data between low, medium, and high retention rates.
Yeah, so hello, I'm Samuel, and I'll present our final data processing method and our current results and our future ideas. So after doing the image classification model, we decided to use object detection with the main goal of increasing our accuracy and efficiency. So here we can see one of our Google Street View images from the University of Cincinnati, and the object detection model has detected some objects such as the 5 people, the lamppost, and the fire hydrant, and it put them into a graph, which is on the next slide. Yeah. So as you can see, this graph, each column has all the objects, and in each cell we can see the amount of objects in each picture. And then our final column, the label, the retention rate, is the actual retention rate of the school. So in this case, there's a 1, so that means it has a medium retention rate. So how does object detection work? So the basis of our object detection model lies in CNNs, convolutional neural networks. And just like the classic neural networks, these CNNs consist of an input, output, and the hidden layers. So in this GIF, we can see a basic simulation of how it works. So first we have an input image, like an input feature map that is divided into numerous pixels in the grid. And then the pink 3x3 grid that's moving across the image is our filter. And this filter is a matrix that represents a certain feature, such as an edge or a corner. And then this filter goes through each 3x3 grid on the input image, and then it creates an output feature map. And then so we have a bunch of different filters. So we have many different outputs, and then the computer then processes all the output feature maps in a neural network to find the objects and create a prediction of what the object is. And so a CNN was much more efficient than our image classification, since we could find the objects without going through every single individual pixel. So the object detection model that we used was a pre-trained YOLO model. YOLO stands for you only look once. And this was an open source model that already had trained to detect 80 different common objects. And then after we found all the objects, we trained the computer with a decision tree model. So now let's look at our current results. So first, with our image recognition model, we obtained a 50% accuracy. However, this model was extremely large and long and tedious. It took around 24 hours to train and occupied a lot of storage. So then we moved to our object detection method, and this had a slightly better accuracy of 60%. And this, it took 4 hours to detect all the objects, but it was much easier to train, only taking seconds. And then finally, with our color detection method, this one only had a 35 to 40% accuracy. It took around 6 hours to gather the colors, but again, it was pretty easy to train, only taking seconds. So now let's move on to our future ideas, how we can improve our research. So currently our accuracy is way too low to make any feasible conclusions. So we wish to raise this accuracy to around 70 to 80%. And so some possible ideas that we're considering right now is, first, we can make our own CNN that's not from the open source. So we can detect other objects such as trees and roads, since we thought that these objects would probably have an effect on the retention rate, but they weren't being detected. Another thing we can do is adding more colleges to our current data set, so we have a wider range of data, and then we can also increase the pixels of the picture so we can get a more precise answer, but of course that will take much more storage and time. So yeah, that's it. We would like to thank Dr. McMahon for helping us with our research project. We would like to thank the ASDRP organization for letting us use their facilities, and we would also like to thank our fellow researchers. So yeah, thank you.
Thank you. Well done. So I do have a couple of questions. First, I want to relate it to my own lab. I mean, if you're aware, my lab is 100% virtual with 88% retention, and that 12% are seniors who are leaving. But you don't see any people nearby my lab because my lab is not physical lab, it's virtual. After COVID, we got this chance of being hybrid and COVID. How do you define that? There are so many people who are taking hybrid courses or online courses. So how do you relevant that post-pandemic new era of virtual and hybrid education with this retention study?
I can take this one. So basically the retention rates that we use in this data were all based on on-campus numbers that the school reported themselves. So really our study is more focused on physical environment, and I guess it's not suited for hybrid schools. But we've noticed though that schools are more and more going back to having physical classes rather than hybrid classes.
But
Yeah.
so just to emphasize that you have to open that window, you cannot just emphasize on the accuracy and prediction that this is how it happens. And also the next thing is that you said that you have chosen a specific location to collect the Google map. So just give an example. I know you choose a specific colleges, but sometimes the colleges have a service like drop off through bus. They have a parking area that they pick up the students after every 10-15 minutes and drop them to the main campus, because either the campuses are big or just at least with Stanford, the parkings are way too far and students can't pay for the nearby parkings. That's for the faculties, and then they move them. So I just want to know that how you can interpret. There are a lot of variables. There are a lot of factors that needs to be included in order to come with that conclusion. So that is one question I have. Second thing that I have is how you did the voxel analysis. How do you know that how your study recognized a person from a lamppost, from a crane, that hanging? So it's just what are the voxel facial or like I would say person recognition algorithm you have used so that make sure that whatever you're detecting is a person and not an object. I mean, by voxel, I mean pixel. In neuroimaging, we call it voxel. In normal life, we call it, I mean, I think we call it pixel. So what is that pixel-based analysis you have done to make sure that that is a person, whatever object you see?
Rochelle, do you want to take this one?
Sure. Are you referencing to our like what is it, object detection? So
Yes, I believe that's right.
So we did use a pre-trained model, so it would already be able to detect like a tree. Wait, can I go back? So it'll already be able to detect like a person or a lamppost or a fire hydrant, for example. So we didn't necessarily, since we took the code from an open source, we didn't necessarily have to train the model ourselves, and it already came with I think it was 80 open objects. So, and like a tree and a person are common. So we just had to input the photos and have it detect it for us.
Oh, so you already used the pre-used.
Yes. Yes.
Okay. Okay. And then these are not a Google view from like Earth view. Like these are like a camera view. It's different thing.
That part, I think someone also in the chat might have had a question about it. But so we put it through a scraper. So on Google Street View, there's multiple factors that we had to think of. So first, Google Street View, so all of our researchers may have different computers and the resolution of the picture may be different. So we had code that would make all the photos into one set size. We had code that would remove usually on the top right or like bottom left, bottom right, there'd be compasses for Google Street View, or there'd be on the top left, it'll show like where it is on like the world. So we had a scraper that would remove everything and put it down to the basic just screenshot photo. And there's two different things. There's Google Earth and there's Google Street View. Google Earth is looking at houses from a satellite view. Google Street View is looking from the ground around. So
you use the Google Earth, but did you check it as a real time, or did you check all the colleges exactly at the same time, all of you, so you know what I'm trying to say? So in order to do a research study, you need to have one variable and keep the rest of variable unchanged. So right. If you check the street view, it's just like if four of us at the same time of a day, you're going to look at the street view of 4 different colleges. Is this what you've done?
So we looked at the most updated Google Street View. They don't really change, if that's kind of what you're asking. Could you like restate your question?
If they don't change, that means how frequent they change?
They that I'm not too sure, but they change pretty often.
Okay.
What he's saying is that they take a lot of Google Street Views, but one looks a lot like the one that they took before.
Mm-hmm.
So
yeah, there's like little
take a
change
series
in
of
the
Google Street Views over time. There's not much variation from one time period to the next.
So here is the thing with the data science studies is we are so excited to jump into implementing machine learning and neural network and all those fancy algorithms. But what we're missing, the core, is the data, is what are the variable and factors we are looking and behind that, just like an image, what are the other things, what time of the day, how frequent, how we can keep all this variable fixed so that we can come to the final conclusion. I'm not questioning your algorithm. It's definitely is, you have done an amazing work implementing the algorithm, but I want to pull you back. Like, I want to make it this one for all 120 people, that data collection requires a lot of, you have to really be like a picky person, and you have to be a perfectionist when you target the data, because if you do one tiny mistake or two variables at the same time that has affected your data collection, then basically your model is just like a model, but not a conclusion. So I would suggest that you go back as a future work to look at the data in a more, more, I would say, picky way, to make sure that when someone asks how often this image is it fixed. So if you are implementing an algorithm on data, make sure that everything is fixed in that one, because red flags will pop up later on. But good luck.
Thank you.
Do we have anybody else that has questions? Maybe you could answer the question that's on the chat window.
Hi. Hello, this is Bharat. I have a very straight question. It's very interesting, very nice picture, and then clear objectives, everything. And I'm not sure, you talk about the retention of students. Maybe what are the factors you found? One is the physical facilities, objective, maybe the lamp post, and then the nice road, those things. Did you consider any other social factor or maybe economic factor, those things in your research, or only the physical objects? That's my question.
So as of right, we had two parts to our project. Our first part was simply studying the environment of a college and their but our second part was finding data as regarding people going to colleges and their economic backgrounds and their ethnic backgrounds.
That one is another project.
Yeah, that's
so you combine maybe later, and you might get a very rigid answer, yeah, so that you can maybe suggest college, universities. Okay, our study shows this one, so it would be better if you could do this, yeah.
Yeah.
Oh, wonderful. Yeah, nice. Thank you.
Okay, so I also have a question. My question is, how do you avoid kind of like logical fallacies or things like where your model may say, okay, there's a lot of, I'm seeing a really low rate of retention and a lot of fire hydrants. So more fire hydrants means less retention. So we need to decrease the amount of fire hydrants, which how do you like things like that, where there could literally just be really coincidences, or there's logical fallacies, or maybe it's not the fire hydrants themselves, but something that causes there to be more fire hydrants is also causing lower student retention. How do you work around those logical fallacies, or how do you teach an AI to do that?
So the thing about having thousands of pictures and that much data is that the more data you have, the less likely these coincidences are going to happen. Because if a pattern happens within the first 5, the odds of it continuing through the first 10 pictures, or the first 100 pictures, or the first 1,000 pictures slowly decreases. So as we plan to add more data, we would expect to see these kind of coincidences disappear. But
even less about coincidences, but more about just correlation versus causation, right? Where you have because as humans, right, we're able to think okay, it's not the fire hydrant itself, it's maybe really close proximity to a fire station, or lots of ambulances in the middle of the night that are causing people to be woke, things like that. We're able to maybe make some sort of connections like that. How can you because if your AI just looks at it and is okay, I'm noticing that and across all these colleges with more fire hydrants have lower retention rates, so fire hydrants must be causing. Are you going to take that at face value, or how do you teach the AI to do stuff, or would that be something that you, the human people in the experiment, do?
Um, I think it would make most sense for the humans to interpret that data, or interpret why that feature is so prevalent amongst higher higher retention rate colleges, because it's not possible for an AI to interpret why. It just shows that correlation, but it's up to a human to interpret why that would happen.
Okay, cool, got it.
Are those all the questions?
I think there's one in the chat. I think by the first question, or the first question you're just asking about the CNN model, the limitations. Yeah, well, we kind of just discussed one, which kind of, if all low retention rate colleges have fire hydrants, that'll classify, maybe it'll accidentally classify a high retention rate college as a low retention rate college if it has a lot of fire hydrants. And again, that's just up to the human to interpret how to look at it. But for the second part, did you mention your feature extraction process? If by feature extraction process, you mean how we got our Google Street View images, once again, it's from our scraper. So we coded it so that it would standardize every single image. So if I were to go back, that's not back. So if I were to go back to this photo, where is it? This photo, for example, the dimensions of each photo are the same. There's no extra in the top left. We've removed the headers, we've removed the compasses at the bottom right, any extra GUI, and we've standardized the images. We also randomize the angles. So in a Google Street View image, you're able to change you're able to change the coordinates and an angle that it looks like. So we were able to change the angle at which this person looks at. So in this Emory photo, a person is looking at normal eye level, but in the Cal State Dominguez photo, they're kind of looking upwards, and that would be two different photos. And we had it randomized different positions and different angles at which they were looking at, if that is your question.
I think for the feature extraction, they might be talking about like how did you like identify the features of like the objects inside the image. So yeah, I think we briefly explained over that, because like we have like our filter and our CNN that finds these features and then puts them into like output feature maps or like matrices for the computer to interpret. But this was like mainly not like but like the object detection model was like an open source, so it technically like wasn't ours, so we didn't train the feature extraction process. But yeah, we're planning to maybe like add our own to like detect other objects to try to increase our accuracy, if that answers your question. What are your next steps to creating your own CNN program? So yeah, we don't have like a definitive answer yet. We're still like planning, I guess, and like looking through like how to create our own program to hopefully help our accuracy predictions.
Is there any more questions? Okay.
Okay, so thank you so much. Perfect, perfect. So we wrap up another colloquia. I hope you all learn new stuff.
What's a
And
colloquia?
anytime that you attend a colloquia,
What's a
you gain a
colloquia?
knowledge. Thank you, everyone. Have a good night and enjoy the rest of your week.
Okay.
Thank you,
good night,
Sahar.
Thank you.
Thank you, sir. Bye-bye.
everyone.